Hello everyone, welcome to the second week of GPY 112 Global Climate Crisis. This week we are going to focus on the evidence of the global climate crisis around the world. My name is Elena Rybimtseva. This is the second week of the course. I would like to start this lecture with these two graphs that are coming from the new sixth assessment report by the Intergovernmental Panel on Climate Change of the United Nations that just came out less than 1 month ago. And this report is based on over 14,000 of peer-reviewed studies around the world, reminding us once again that climate change is widespread, rapid, and intensifying. Unless we make immediate, rapid, and large-scale reduction in greenhouse gas emissions, limiting warming to 1.5 degrees centigrade might become beyond our reach. So on the left side of the graph, you see that woman is really unprecedented in more than 2,000 years. You can see here the changes in the global surface temperature that has been reconstructed from geological records and observed since 1850 to the present. On the right side of the graph, you see the changes in the global surface temperature as they are observed and simulated by climate models, both using human and natural versus only natural factors. And you can clearly see that we cannot explain anymore this climate change purely by natural factors. There is a huge gap, and especially over the past half of the century, part of the past 56 years, we can clearly see this very rapid increase of the temperature, this hike of the temperature since the middle of the 20th century, which is clearly driven by human activity, human impact on climate. As you can see from this compilation of data from various climate data sets, from NASA, from Hadley Center in UK, from NOAA, from Berkeley Earth, and from Cotten and Way, you can see that there is a very strong agreement of meteorological data about how the temperature has been evolving during the past century. So these data are reconstructed from meteorological observations since the end of the 19th century, clearly showing us that global average surface temperature has risen by about 1.1 degrees centigrade, which is over 2 degrees Fahrenheit since the end of the 19th century. And this is an average. The temperature increase in higher in the northern hemisphere than in the southern hemisphere. It's significantly higher on land rather than over the ocean. And it's also significantly higher as we are moving closer to the poles than closer to the equator. Most of this warming, as you can clearly see from these graphs, has occurred over the past 40-50 years. During the same time, atmospheric concentrations of carbon dioxide have also increased in the atmosphere. And at this point, this is really unequivocal that this warming of climate change is happening as we speak. I want to again bring a different version of this graph showing us the separation of human and natural influences on climate. Climate is changing because of a variety of different reasons, and these factors are both natural and human. But since the middle of the past century, we cannot anymore explain climate change by natural factors. It is becoming more and more clear every day that the human factors are now a predominant geological force affecting our climate. If today we could somehow subtract magically human forces from natural forces of climate change, you will see that the temperatures would be almost 1.1 or 1.2 degrees centigrade lower than they are today. So at this point, it is absolutely unequivocal that climate change is happening and is driven by human activity. As this very rapid, critical global warming has been progressing over the past century, we also see very clear correlation between the growing concentrations of carbon dioxide and other greenhouse gases produced by humans polluting our atmosphere. And it is really unequivocal that the temperature increase is related to the increase of concentrations of greenhouse gases. Atmospheric concentrations of CO2 have increased by almost 50% and are about to double to the pre-industrial carbon concentrations in the next few years. As you can see from this graph, which is based on the reconstruction of CO2 levels from the geological records, the present concentrations of greenhouse gases today are higher than our planet has experienced ever in the past million years, which is very well documented in the ice cores and many other geological records. Here you can see the daily record of the global atmospheric carbon dioxide concentrations on the observatory on top of the Mauna Loa, one of the highest mountain peaks in the middle of the Pacific Ocean in Hawaii. This record is also carefully aggregated with other measurements of carbon dioxide from other measuring stations and air balloons, and aggregated at the Scripps Institution of Ocean Science in San Diego. So you can actually go to the website yourself. It's quite fun, and you can see the evolution of concentrations of CO2 monthly, daily, since the beginning of the record, and you can see how it has been quickly progressing since 1960s, when the measurements have started in 1960. So today, or just a few days ago, when I was preparing this lecture, the concentrations of CO2 measured at Mauna Loa Observatory were 14.86 particles per million. This is significantly higher than 310 particles per million that were recorded when these measurements started in 1960. And of course, you see that the concentrations of CO2 are going up and down every year, and this reflects respiration and photosynthesis by our ecosystems. But every year, the concentrations overall over the year are getting higher and higher and higher and higher. And so we are really very close to doubling concentrations compared to the pre-industrial level. The heat-trapping nature of carbon dioxide and other greenhouse gases has been known over a century, and attribution of the current warming to human carbon emissions is very well established. It's extremely well understood. The human enhancement of the greenhouse gas effect is absolutely unequivocal, causing more and more heat being trapped in the atmosphere due to carbon pollution, primarily from burning fossil fuels. Greenhouse effect on its own is a normal phenomenon. This is what gives our planet this Goldilocks effect. This is an ideal planet for life, for human society. It's not too warm, it's not too cold, and the greenhouse effect provides this warm blanket trapping heat in the atmosphere. Unfortunately, when greenhouse effect is intensified by humans, and this is exactly what has been happening since the pre-industrial time, more and more greenhouse gases are becoming trapped in the atmosphere, and the greenhouse gas effect is becoming stronger and stronger every year, trapping more and more heat that cannot escape anymore back into the outer space. Think about the scale of atmospheric pollution by carbon and other greenhouse gases that we have been experiencing. We are dumping about 110 million tons of man-made global warming pollution into the atmosphere every 24 hours. On the left side of this graph, you see where most of this pollution is coming from at the global scale on top of the graph, and for the United States. So 25% of all global greenhouse gas emissions are coming from producing electricity and heat. The number is slightly higher in the United States, it's about 29%. 21% is coming from industry at the global level. It's also 21% for the US. About 14% globally is coming from transportation emissions. This is significantly higher, 27% in the United States. 24% is coming globally from agriculture, significantly less in the US, about 9%. And then other including their commercial and residential, this is also about 10 and 12%. These graphs are not perfectly aligning because the reporting is slightly different in different countries. But I think you see, in general, global picture of where most of these carbon emissions are coming from. They're coming from our transportation, from our cars, they're coming from industrial processes, they're coming, huge amount of them is coming from the coal plants, from coal mining, from fertilizers that are used in our agriculture, from landfills, from oil production, from air transport, from cement production, and so on. As you can see from this graph, that the carbon emissions are also very unequally distributed all over around the world. So China surpassed the United States several years ago and is now responsible for 28% of the global emissions associated with fossil fuels, followed by the rest of the world, and this is a very large number of countries, followed by the United States, and the United States is still responsible for 14% of global emissions. However, if we look at the emissions per capita, the emissions in the United States are significantly higher than emissions in China because the population of the United States is much smaller than the population of China. Now, most of this heat, which is trapped by carbon dioxide and other greenhouse gases in the atmosphere, is going to the ocean. Ocean heating is happening at the scale of comparable to 4 Hiroshima bombs per second. This is mind-blowing. Just take a moment to think about these numbers. Is the yield of a Hiroshima atomic bomb was 6.3 10^13 joules. The rate of the ocean heat accumulation is equivalent to about 4 Hiroshima bombs detonated every second, or nearly 2 billion atomic bomb detonation worth of heat accumulated in the Earth climate system since 1998. So since 90% of this heat is trapped by the ocean, this is what really is protecting us right now. If we didn't have all this ocean, if the land, if the surface of our planet was not covered by the ocean, the heating will be significantly higher. The oceans are also by far the largest sinks of carbon dioxide through the absorption of the gas into the water surface. But unfortunately, the ability of the ocean to remove CO2 from the atmosphere decreases with the increase in temperature. So increasing CO2 in the atmosphere causes very powerful, irreversible amplification, exacerbating the buildup of carbon dioxide in the atmosphere, and in turn accelerating global warming, accelerating climate change. The oceans are a very important part of our climate system, and there is only so much heat and carbon that they can take before the system collapses. There is really overwhelming evidence, whatever indicator we examine, that climate change has been accelerating. So land surface air temperature has increased, as you can see from this graph. The sea surface temperature also has increased. The sea level tropospheric temperature has increased. The ocean heat content has increased. The specific humidity has increased. And the northern hemisphere snow cover has significantly decreased. The glacier cumulative mass balance also has significantly increased. So there is an overwhelming evidence that the Earth system are now close to reaching the tipping point that would lead to irreversible amplifications of climate change unless we substantially cut carbon emissions right now. For example, melting of the snow and glaciers not only increase the sea level rise and disrupts ocean currents, but is also causing the surface of our planet to absorb even more heat due to the loss of wide, highly reflective surfaces. Tropical rainforests and Arctic peatlands are very important carbon sinks. But when forest is cleared, or when the forest is burned, and when the Arctic peatland is melting in Russia and in Canada, in the Arctic regions, more and more carbon is released into the atmosphere, and this is carbon that has been accumulated for many thousands of years in the frozen soils or in the peatlands, and now this is going to be released and it's further contributing to the warming. So those are just a few examples of positive feedbacks that are causing amplifications of the climate crisis. If you want to find out more beyond our book about the latest scientific updates on what is happening with our climate system, I strongly encourage you to browse the new 6th assessment report of the Intergovernmental Panel on Climate Change that was released just a few weeks ago in August. And this is the report by the Working Group Truth, Physical Science Basis. It was released at the beginning of August of this year. It is based on more than 14,000 peer-reviewed articles. And this is where you can find significantly more information on climate change. This reading is not required, and I don't expect you, of course, to read the entire report, but I strongly recommend you to read the summary, or perhaps just read the summary for the policymakers. Have a good week, and I will see you next week, and we are going to talk about the impacts of climate change.